Hi, good afternoon. Okay, we are going to. I hope that you can hear me properly. Let me know if there is any issue with the audio. Just here is 4 a.m. In the morning here in Spain. So good afternoon there in Brisbane. Here we are starting the session of the Traffic Engineering and Signaling Working Group. So we'll start with the usual reminder of the IETF not well. So just to remind everybody that if you participate in the IETF and in particular in TEAS, you need to follow the IETF process and policies. And if you have any contribution that is covered by any patent, you need to disclose it. And here you have all the not well to go through it if you have any doubts. So the guidelines, we know we like to have the heated discussions, but here we need always appropriate behavior. Okay, so here we expect to maintain the courtesy to all the colleagues in the discussions. Keep the discussions in personal. Okay, please just leave it to the technical level. And here just contribute to the then here if you are lucky to be in person, just use the data tracker there, just log in your phone, computer, use the Meet Echo to join the queue. And all of you that are online or remote like me, just you turn off the audio and video uh, in when you are not presenting the session, and use headset to sound properly. Here, here you have the the place for the minutes, and please also everything that you can capture now help us, okay, facilitates us our life of capturing the minutes. And here you have all the materials for the session, also here in the data tracker, or also in the app. Also, it works. They are having it in the app. You have the data tracker with all the document and the streaming in Solid. So moving forward, this is the agenda that we have prepared for today. So we have prepared several blocks today. So the first block is devoted to the packet optical integration. So we have to these documents first, the applicability of ACTN that is going to end up. This is quite mature one. And then we have the last one of this part is now more second, but is the use of in the context of ACTN and POE, the special case with the pluggables. Then the next part of the session is devoted to the slicing. Okay, so we go for the YAM model, for the slice topology, composite slices, and then we have a part also quite close related to the slicing, the 5G QAE to DSCP mapping for this end-to-end slices, and the model for topology filter. And finally, we end up with the MPLS Farrell bypass calculation with boundaries. So I hope we have a quite complete and varied agenda. So I would like first to start by saying congratulations from all the chairs to all the people involved in the two new RFCs that finally here you can see the the whole process it has taken. So it's been a journey of almost 5 years since 2009 that the design teams of and the overview and principles of traffic engineering, the update of the RFC and the framework for slices that has given a lot of work. As you have seen, we have a full set of documents related to slicing. Now both of them they are RFC, so congratulations again to everyone that has been involved in both pieces of work. So later on, Pavan will go with more detail, but here just the document status. Here we have 3 documents that are now submitted to IgG for publication: the PC as a controller use cases, the enhanced VPN, and the GMPLS control interworking. And we have several documents that are in the process of the working group last call, the CTN Virtual Network Jan, that this is a new revision published this week, just waiting for write-up. The applicability of ACTN slicing. Also, there is there was just a new version published this week, and now we are started to have triggered the routing directory review for that one. And we have a couple of documents, the T-Yang and the T-Path computation, that they have dependencies on another document. This is the update of the T-types, okay, that it is in the in working group, well, it's going to be now for working group last call. So the process have just initiated. We have started today the IPR poll after the authors have just from their view everything now from their parties is complete. So now I hope that with this we can, with this document, with the RFC 8776 update, the T types, we can unlock the T and the path computation. And we have also a couple of documents that have been recently adopted since last IETF, the NLP Young model, and the MPLS, the MPLST topology model. And then we have also an adoption poll ongoing for the T topology profiles that also was presented in the last meeting, and we are just now starting the poll. So here we have some liaisons. We have first since the end of last year the input for the OT&T standardization, where we gave the for the around the or the responses were around the IETF network slice, and there are also a couple of liaisons for IETF study group 16. So are there any comments on the liaisons? I don't know if we have here today any contact point for those, or there is any additional comment for the liaisons. If not, we can move forward. So here any information for the liaisons, you got it here. And just to finalize, couple of reminders, the IPR disclosure process. Okay, so here we do early the IPR disclosure during the working group adoption. So here we do it just before, and then we go also the poll before a document goes to last call. So here we require everyone listed in the draft as contributor or author to reply. Okay, so here Just we have had some problem in the past when some contributor moved out or retired from the organization. So please be aware that if you are happening when you contribute. Even if you go out, you still need to be there. And if you don't want to participate anymore and so on, maybe you can ask your name uh, to be removed. But please reply even if you go out. Just to finalize the reminder, the GitHub that we are using. Also, I have just, I think, if you have any problems also with the access or you need some admin rights from run repository, just talk to us. Uh, and here you need to all the working group documents you need to provide the status. So with this, I leave the floor to Pavan. I think. Okay.
One comment on that last slide. This is a planned process change. And we are going to ask that we have status updates either as a presentation at the meeting or in email, and we'd like the email earlier so that there's time to discuss if there's anything that needs to be discussed before the meeting where we're set up. So that's a process change from where we've been before.
Thanks, Lou. So next on the agenda is the working group document status. We've had two new RFCs and two new working group adoptions, so we have the same number of documents that we had the last time. There are 28 working group documents listed here. Of these, there are three documents, the enhanced VPN document, the GM Pillars controller interwork document, and the PCECC use case document for which we have put in a publication request. There are two documents that are on the agenda today. Those would be the POI applicability, the ACTN POI applicability document, and the network slice service Young model document. So that leaves us with 23 documents, and the status of each of those 23 documents are covered in this slide deck. Of these 23, there are four that are in what we call a post working group last call stage, and one document for which we just initiated working group last call. So essentially, there are 18 documents at varying levels of maturity that need to progress to working group last call. Of the four that are in post working group last call, there was a revision published for the ACTN VN Yang document earlier this week that should address the comments received from the shepherd. So expect to see that get progressed to the next stage pretty soon. There was a revision published for the applicability of ACTN to network slicing document as well. That came in maybe yesterday or maybe the day before. Uh, that should address all the comments that were received during working group last call, and we have initiated an early routing directorate review for that document as well. The two other documents that are in post working group last call, the T Young document and the path computation Young document, they're waiting on the progress of the RSC 8776 update document, for which we just initiated working group last call. Those three documents should progress to the next stage together. I don't plan on walking through the status of every document that's listed in the slide deck, but as usual, I will double click on a select few that need immediate attention and dwell on them. For the rest, you can go through the slides, go through the status reports that were sent to the list, and if there are any questions, please do ask them here or on the mailing list. That said, let me jump to slide 4. This is the document that talks about realizing network slices for 5G networks using existing technologies. We did request few early reviews for this. We received feedback from in TSV and the routing directorate. We did not receive any response from the ops directorate. At this point, we are not going to wait for that. The authors have confirmed that they have responded to or clarified all the questions that were raised during the review process. They are acknowledging that there are some minor edits to be made and are also requesting working group last call. We would like to ask the authors to go ahead and make these minor updates before we take the document to last call, we'd also like to request the working group to review this document in anticipation of an upcoming last call. The next document I'd like to draw your attention to is the ACTN performance metrics telemetry document. This has been ready for a while. We were waiting on the VN Yang document to complete working group last call. Since that has happened, you should see this also get progressed to the next stage. Again, please review this in anticipation of the working group last call. I'd like to draw your attention to the NRP documents. This is the NRP scalability document. As stated earlier on the mailing list, we are looking at the evolution of the NSIP MPLS draft, the NRP scalability draft, and also the newly adopted NRP Young document to help uncover any gaps, if any at all, in control plane and data plane, and for realizing slicing using network resource partitions. Um, so in that sense, these are key documents for to help provide guidance and understanding of the various extensions that are being proposed in other working groups. It's totally up to those working groups to decide which extensions they would want to pick and work on. From all that the TEAS working group would be able to offer is some overall guidance on how NRPs can be constructed in different protocol environments. And that should help these working groups make an informed decision on what to adopt and what not to adopt. We did have an example of this recently. There was an IDR document for which explicit feedback was sought, and feedback was provided. We expect to see the same process happen for the other documents as well. Coming back to this document, there was a revision published for this early in the month. There are some substantial changes to this. There's also an appendix now that talks about scalability issues specific to certain network realization scenarios. So please do give this a read, review it. If you have any questions or concerns, please do take it to the list. I would now like to draw your attention to 4 documents that do not have any open issues listed at this point, and thus are candidates for working group last call. Um, the first of those would be the one slide 20. This is the RSCP Yang document. There was a revision published for this last month. This is now deemed ready for working group last call. So please do review it as we prepare this for working group last call. The other 3 documents that are also uh, ready for working group last call are the 3 topology documents that have been around for quite some time now. There's the SF aware topology model, there's the L3T topology model, and also the SRT topology model. So expect to see these 4 documents get lined up for working group last call um, as soon as the first set of 3 Yang documents get out of the door. So those are the documents that we wanted to draw your attention to. We do have a fair number of documents you'd like to take to last call between now and the Vancouver meeting. Um, so that's all we had in terms of slideware here. Are there any questions on these documents or any of the other working group documents? Okay, I don't see anybody walk to the mic. Let's go to the next presentation. Clicker is not working. I'll change the slides for you.
Okay. Thank you. I'm Italo Busi. I'm presenting the status of the work on the ICT MPO applicability statement. Next slide. On behalf of COTUS and COT. Okay, a recap of what we are going to do with this draft is basically an analysis of how the IETF YAM models can be used in a scenario where we are having IP and optical integrations, where we want to use the optical network to provide a dynamic link setup for an IP network. And the use cases that we are addressing in this draft are inventory, service, and topology discovery of multi-layer layer 2 VPN services, which can go over optical network. So you can see how the layer 2, layer 3 VPN services goes down over a given fiber to an optical network. And also how it is possible to create and set up layer 2, layer 3 VPN services which have some tier requirements and drives the creation of new optical tunnels in the network, in the optical network. Next slide, please. Okay, what we did, okay, we presented this draft, latest update in IETF 116 was version 08. We did some major changes since then, based on some discussion we had on our weekly call. So we clarified how we use the layer 3T topology model in this context, which is one of the drafts that I mentioned before, reading for working group plus call. We added description that the optical network can have a mix of fixed grid and flexible grid. There was a strong requirement from the operators to allow this mix of type of WDM networks. We clarified that when you configure the lag, you may need to configure, for example, the minimum number of active links, and we identified a gap in the existing YAM models which do not provide this capability. And we added a description of how optical service of WDM network can be set up using a musponder. We identified a gap to report some of the musponder constraints, and that gap has been already addressed by the SICAM working group draft. So it is a gap we identified in this work, which has been already fixed. We generalized the description because the optical network can provide both frame-based and transparent services when you carry traffic from the routers. And we have added some text to describe how the MDSC can configure the PNC to steer the traffic from layer 2 VPN over, or layer 3 VPN over a given T tunnel, because we want to ensure that the traffic goes over the right optical tunnel. And we describe how the problem of multi-layer SLG, because when you set up an optical path, there will be SLG that you know from the optical layer and needs to be reported to the packet PNC when they have to set up a working and protection path, which are SLG disjoint. And we made a few editorial updates. And there are all the issues are tracked in GitHub. I think I need to update the GitHub. It's now under TEAS working group. Next slide. Next steps, we have a few editorial updates to be done, so some terminology cleanup. We would like to add some operational considerations, and we need to improve the security considerations. So we will start our bi-weekly call from April 9. They have been already announced on the TEAS working group mailing list. It's open to everybody to join, and we think that we will be able to request working group plus call by the next IETF. And we solicit any comments and feedbacks on our work. Thank you.
Any questions for Italo? Okay.
Thank you.
Thank you. Thank you. This is the second of our ACT and POI topics.
So we continue the discussion on POI. So Paolo Volpato, I'm presenting on behalf of the list of the authors you see here in this slide. The next, please. So basically, what's the dependency of this draft with regards to the one just presented and introduced by Italo? So basically, you see at the top, ACT and POI is basically everything about, inventory, topology, deployment of a VPN service across a network where two different layers are enabled and active, the IP layer and the optical layer. We took the decision to, let's say, develop all these related to service assurance, so dealing with the failures in such a network out of the previous draft, otherwise probably it would have exploded because there is a lot to deal with, a lot to discuss. So we moved the cases, the failure cases, out of the parent draft and moving into a next one. I guess this slide was presented by Italo at IETF 116, so probably it's not completely new to the audience, but just to refresh that, the start of this activity together with another one that will be discussed later on the pluggables, was considered as a sort of step 2 of the POI activity. So that's the reason why we decided to develop the draft and present it today. Next slide, please. Oh, I see there is a comment. Do you prefer I answer right now? Or?
It's up to you.
Okay, so if there is...
Take the comment.
No, disappeared. Okay.
Good.
Okay. So reference architecture, basically it's the same picture shown by Italo before. So we're dealing with a network where we have different domains, a packet domain, working together with an optical domain. The key issue here, if you have read the POI, you know that the connection between, let's say, the two networks or the two operators domain or whatever happens at the IP layer. So everything is configured so that the communication, the exchange of information happens at layer 3, not at the optical layer. While the packet domain clearly uses the optical services to exchange information. For example, from the CE on the left or the right of the picture to the PE and then to the border router. That's the reference architecture. Let's move to the next one, please. And we have here the reference network we are considering for dealing with the assurance cases. At the moment, we have found 4+1 use cases to discuss. So let me just propose the question that will be also referenced later in the next slide. If you think those cases are relevant, if anything is missing to the discussion, because clearly there is a lot of material to be discussed. So what are the cases? Starting from number 1 and number 2, the top right. So we have the cases where an optical link has a fault. So there is a break, an interruption of communication, the fiber breaks, something like that. So we have the exchange of the service flow between R1 and R2 has to take another path. Clearly, we have to consider two cases here. We have protection and restoration at the optical level. So we have to deal with the difference of both of them. Then there is another case, which is number 2, which is basically the same. So the service has to be interrupted, but not because of a failure, but because there is a maintenance activity. So the operator clearly does it on purpose. In any case, some actions have to be triggered to preserve the service. So clearly there is a fast rerouting operation, so something happening at the IP layer, but we have also to coordinate, let's say, the mechanisms at the optical layer. And the discussion about the first two cases is about that. Then we have case number 3. You see that the router on, let's say that that is a point of presence. We have a router R1 connected to a RODM 1. There are a number of links between them, and one of those links has a fault, has a failure. So we have to deal with that. And in that case, we are not using lag. There is one spare port protecting the others. Let me introduce here just a small digression, because even among the authors of the draft, we had a lot of discussions about this case. It was originally proposed by Telecom Italia, by an operator, so we decided to keep it for the moment. But we are not sure whether it is worth or not, because it's a bit complex and probably the applicability in the field is not so, let's say, widespread. So it's a question we are posing, whether there is interest, we continue the discussion and we analyze that case or not. Then we have case number 4, the failure of an entire router. It's not likely, we understand, but it's a case proposed again by Telecom Italia, so we decided to keep it and to discuss what happens in case a router has a failure. I was mentioning before 4+1. The 5th case actually is how to deal with the reversion of the configuration when everything is solved. So let's say we have case number 1, an issue on the optical fiber, so we decide to switch the service on another path, and it's another optical path that happens after the coordination of the IP and the optical layer. Let's assume the fault is solved. The operator may want to bring back the service on the original path, on the initial one. So we have to deal with the multi-layer reversion. Great, if you want to... No, please, if you want to ask. I guess it's related to this slide, so.
Yes, Kiriti Compella. In the case of the cross-layer link, you have P1 on R1 is that the same whether it's a gray optics or a WDM optics?
That's gray optics.
Gray optics.
Yes. The
Okay.
decision was to keep everything which is, let's say, out of the gray optics applicability out of the draft. You see, Italo is laughing. Right.
So that's in CCamp?
Yes.
Okay.
I guess, please correct me, I guess it's the next presentation that is dealing with the pluggable. So,
It's a CCAM document, but it will be presented here.
yes.
You have another question?
Okay.
Yeah, I think you're mentioning about the gray optics on the router. So, but the picture seems to be indicated like a coherent pluggables directly connecting to the ROADMs. So maybe you could consider updating the picture a bit to clear the confusion.
Right. Yeah. If it is a matter of making the picture clearer, yes, for sure. Yeah. If there is that doubt, yeah, I think that's not an issue.
Yeah, right. Because for the other draft, the POI pluggables are using more or less the same picture. Right?
Ah, okay, okay. No issues. Thank you. Okay, so next slide, please. Okay, the first edition, version 00 of the draft, was presented, I guess, 2 meetings ago. It was basically a little more than the skeleton of the draft. We have worked quite a bit on exploding the text. So basically, you see in green, those are the parts that we have developed specifically for this meeting. Basically, it's chapter 3 and all the cases I've discussed before. So from section 7, from 7.1 to 7.5, basically is the description of the cases discussed before. There is something to be done. So the central part of the draft is about the, let's say, development and discussion around the young models, and probably that will be the subject of the next version of the draft. Next slide, please. And just to conclude, so the release we have uploaded is version 02. The next one, for sure, will address the comments that we have received here and offline. We will develop the missing sections. But there is one thing that we'd like to share with you. Again, let me again propose the question. If the use cases are relevant, if anything is missing, and if you see maybe something that is probably not worth discussing. As I mentioned before, the case about case number 3, about the connection between a router and a ROADM using multiple links in parallel. I do invite everything to join the activity. There is a GitHub folder we are using to introduce and commit the changes. And also there is the bi-weekly call that is also mentioned during his presentation. It's a bi-weekly call, and we are trying to cope with both documents just to continue the discussion. And I'll say that's it. Thank you.
Any questions? I think we asked this question earlier. I don't remember the response. Why is this not in scope of the previous document? Is it just for readability's sake? Why do you have a separate document?
This is a very good question. Yes, basically, because we believe keeping them separated makes things a bit more readable and clear. If we continue the discussion around the assurance cases, I think that could delay the previous document quite a bit.
Fair enough.
So.
Yeah.
But we are open, clearly, to any suggestions.
Okay, thank you.
Okay, thank you.
Okay. Thank you very much. So we are going to continue now the packet over optical integration with the next level. So I'm gonna present you now this and I'm gonna present you also the history of this draft that comes after after a few ones. So as you see that this draft is led mainly by operators with and also has contributors with different companies. So it's quite a consented document. So what is the why do we need this work, and also why do we think it's worth presenting it in TEAS and keep collaboration with TEAS and not only in CCAM? So first, the new coherent pluggable technology, especially in the 400 gig, even 100 gig is coming, is quite mature, is already deployed in the field, and is ready to be part of operators network in a more massive way. So here, the thing is, we are going to have not as in the previous case separated IP, IPMPLS on packet and optical, but we are going to have integrated IP optical devices, which changes the picture. Okay, it makes things. So here, or what the operators want is to have this end-to-end SDN control, including also this coherent pluggable in the router. So this work, okay, that we are presenting is a continuation of of both drafts that you have just seen before, considering these new scenarios where the pluggable is integrated. We started some discussions in the last IETF meetings, but there were like two groups of people, and the discussion got stuck in a controversy about who controls the pluggable, if it's the optical controller, the packet controller. So we decided to move away from that discussion. We buried the hatchet and said, "Hey, we move forward, and we focus on having scenarios, use cases, do the gap analysis of those, and have the modeling work and have a good modeling work under the ACTM framework." Okay, so here, okay, we assume that the router and the pluggable will be controlled by a device controller, full stop. So here we have started with a draft with with the network scenarios and use cases that is in defining a common draft that is led by operators, and there is also a work in parallel that has started, the modeling work that it is now focused on modeling the pluggable in the router. So here, even this work is mainly done in SICAM because the pluggable is more, say more is optics. Uh, we believe that the coordination with TEAS, where the CTN and POI are defined, is really needed. Okay, so we want to ensure and we want to keep aligned. Okay, so here, just as we will see, the use cases are very related, and multi-layer traffic engineering. I mean, I still believe that the best place to talk about multi-layer traffic engineering is really TEAS. So you have seen the picture before, and now, as you see on the right side, the pluggable work is split into two babies. Okay, so one of them is the document that is submitted and is presenting with the network scenarios, the use cases, and, and gaps under the ACTM framework. And the other document, which is going to be published soon, is about that focuses on the modeling, on the young modeling of the coherent pluggable. So with these two pieces of work, we complete, and maybe from the modeling we will have also more spin-offs, as if we require more young model stations here or there, there there might be more coming from there. So traditional model is the one that you have seen before in the packet over optical integration with the gray optics. In this new one, we are going to have the optical network shared, and we are going to be used in two ways, okay, with a traditional model and also with a new model where the optical connection or the signal starts, the optical signal starts in the packet device. Okay, so the packet device has the colored optics inside, and starts from there. So what are the scenarios that we are targeting? So here we are targeting mainly four scenarios. So first one is a high capacity point-to-point connection over a dedicated fiber. So there is, let's say, nothing in between. So the fiber is just for you, even you don't require any amplification. The second one is over a shared fiber, so you multiplex several connections over the same fiber, but it's a point-to-point. There is no cross connection, so it's also easy one. Third scenario, the scenario that we call scenario C. This will be the more common, we believe, the more common scenario in carriers network, where you have your mid-regional meshed networks with ROADMs, and there we are going to have this point-to-point connectivity between pluggable and pluggable between two routers. Okay, so we believe this is the most common scenario. And the last scenario that we think it's useful is where on the one in one hand you have the pluggable interrouter, and in the other side maybe the router is not yet equipped or is not ready to have or to support these colored optics. So you end up in a traditional transponder or muxponder, and then you go to the gray optics to the router. So this scenario, for example, now that also we are moving also the 100 gig pluggables are, I think, about to come to the market. It is likely that you have operators. We are not changing routers every year, okay, so it will be very likely that that the situation is also starts to be somehow common. Also in the draft that we have started to, in addition to these scenarios, we have started to compile, okay, which are the use cases to focus. Okay, so here what we have done is get the operators together. Okay, hey, compile the use cases, prioritize them. Okay, so just consider this is a 0.0 version. Okay, so this work just has started. And first, for each of the use cases, we have identified whether it applies for the general packet overall integration or is just specific for the pluggables. So the priority number one that was set by everybody is, okay, what I really need to first is have the end-to-end visibility with all the layers. Okay, so what I want to see is the relationship with all the layers, and in particular, okay, as the pluggable is integrated, this is the detail that I want to be able to see in all this layering. So here, as part of this process, we differentiate between the use case, whether the more discovery and inventory. Okay, so here it is the discovery of all these layerings and the discovery of the inventory, and especially there the case where you plugged and how what happens when you plug the pluggable in the router, and how all the structure is created and appears. Also have the multi-layer the fault management, okay, and the performance management, both of them also for this case. Then we have the interdomain link validation. Here, just to say what is validation, not discovery. Okay, here it is the connection between the pluggable in the router and the ROADM. So right now, I mean, as they are, it's gonna be a passive port release in the ROADM. It will be just a spectrum between both. Discovery per se seems seems more complicated. Okay, so we assume that the operator is something that it is already documented and known. So it's just a validation to is a validation process to check there are no errors, but we assume that there is some knowledge before. And finally, we go for the service, for the provisioning itself, where we have the pluggable to pluggable service provisioning. So just so you create this connectivity between both, and then you create an IP link on top. And also, I think which is where things start to get interesting and the more relation with this is when it's part of the end-to-end service. Okay, whether it is a layer 2 VPN, layer 3 VPN, or a slice that has some constraints, and mm, as you happen to have the pluggables in the router, you can take take benefit of that to add the required capacity. And the last one is where, in addition to being able just to set up, you can use the restoration capabilities of the plugin. So here, this will imply also, and I think this might trigger a lot of work. And I think there was a question by Kireti before about, okay, hey, now what happens for example, weather restoration? What are we expecting to happen now that we have the pluggable directly there? In the case of restoration, we can do the restoration directly from the routers. Okay, what are we expecting to happen? Okay, so here, okay, what we want to really device is to prepare or to present the use case of having this provisioning of the service with some constraints, and that when they are not satisfied, that you can also directly from the router do a change and have it coordinated with AP. So clearly, this is part of the work. So here with this, as I just finalize, so and then we can go to the discussion. I see that Kireti entered the queue. Just as I have just this page, I finish, and then we go with Kireti. So here, I want just feedback from the ITF. We want feedback from the ITF community beyond just the optical. Okay, so this is why we don't want to keep confine the document in CCAM, which is very optical focused, because I think this is multi-layer. Provide additional use cases. We are open to contributions, get the reviews on the draft, just polish the terminology, align with the parent documents, and also all suggestions from TEAS to progress this work is appreciated. And with this, I finish and let Kireti the first question.
Thanks, Oscar. So Kiriti here. My question was not so much about optical restoration, but just setting up the optical connection, launch power, the basic things you need just so that I mean, you had earlier, should the WDM optics be controlled by a router or a router controller or an optical controller? Probably an optical controller, because routers don't know anything about launch power. It depends on what's happening in the optical network. But that initial setup is the first thing, and then restoration gets next thing. So is this discussed in the CCAM document?
Yes, but the thing of the who controls, whether it is the optical or the packet, we deliberately left it out, okay, because we had we got stuck there, okay, and so we decided to keep it out of the discussion. By now, I'm focused on the modeling itself and the use case of what happens when this use case that you have just mentioned, what happens with it.
Okay, I'll read the document and come back with more questions.
Okay, thank you.
Thanks, Oscar. If you have any feedback for this document, you can take it to the list, preferably the CCAM mailing list. No, I'll do it. I'll do it for you. Just
hello, everyone. My name is Reza Rokoui. I'm with Sienna on behalf of co-authors of this draft. network slice NBI. I'm going to present the progress that has been made since last IETF. Next, please. As the summary, as you see, the revision that we had for 119, there are lots of comments from Matt. Thank you for his contribution. Major issue that he raised is addressed here. The first one is, as you're aware, the RFC for the network slice services has been published a few weeks ago. So we aligned the definition of that with RFC 9543. A few comments and enhancement that we did to the Yang model in a specific, there is attachment circuit that there is a few draft in that context. So we aligned our NBI model with that. As a general rule, you can have the attachment circuit and as a service, and it could be that we have both in the definition of the I don't know what happened to the slide.
It says unstable connection.
Okay, so but assume that you will see it here. I will go through that presentation. So one thing is about attachment circuit. So it is possible that we have a pointer to the attachment service or very clear definition of attachment. So in both cases, we are going to address that. And if there is a definition, which one takes precedence? So this is the first thing that has been done. The second one was, if you remember from 118, there was a cost-based for the policy definition. When we have a policy for SLA, SLO, the question was whether or not we need to have the cost as a part of that definition. So we agree during that discussion that yes, we need to do that, and we modify for the both incoming and outgoing. We changed some of the connectivity construct for monitoring to gauge 64 for the completeness and to be aligned with other draft. And last but not least, the geolocation that is already RFC is added. So as a general rule, these are the very high-level comments. There are some minor comments that also addressed here. Another thing that I'm going to discuss it momentarily about the path constraint, that we add some clarity for, especially for the diversity. I have a specific slide to discuss that, so I'm going to ask to go to the next slide. So the first thing, as I mentioned, that for the incoming and outgoing monitoring, we changed the type to gauge 64 to be aligned with the other IETF drafts. This is relatively simple. Next one, please. About topology. This is, if you remember, let me refresh your memory what we try to achieve here. When we are creating a network slice services between multiple STPs. So the idea here is when we creating in the Yang model, we basically defining an intent. I want to create a network slice services between STPs with a specific characteristic for SLA, SLO. You are defining the intent, and that will be, it go to the network slice controller, IETF network slice controller takes that one and realize it in the network. The idea here is, in addition to that, is it possible that we, as a customer, we specify some realization constraint in the context of the topology? I want to explicitly say that create that network slice in a specific constraint or a specific topology. What is that topology? Who defines it? We have a pointer that could be any topology that you want. But the idea is, can we just go put the first level of the topology awareness to this model? And this is exactly what is described here. We have a pointer to that topology. That topology could be defined out of band and could be referenced here. So this is one aspect that we want to make sure that we clearly have a demarcation between this idea, and there is another draft that Italo and Iowa are going to discuss later on, that if we want to, in addition to that, if we want to create for each of the connection that we do between STPs, is it possible to specify some additional constraint for specifying the path constraint, for example? That is another draft that basically orthogonal to this discussion, is complementing this one, but we want to make sure there is a very clear demarcation of that work that is going to be, discussed and become part of the working group later on. But in this case, we want to make sure that we address that, and we assume that this is already, is closed. We already talked to Ivo and Italo, and with Pavan as well, that this is basically is a good strategy for this model. So in summary, this is a topology related, is closed, and we assume that this is satisfied with whatever has been discussed before. And the next issue is about, as I mentioned, about the path constraint diversity. We realize that diversity is discussed in the framework for the network slice services, and as a result of that, we realized that that is missing, and we added this one as the type of the path constraint here to basically for the completeness of the model that we have. So if I go to the next slide, with all this, we feel that we are ready for the working group last call. If there's any other comment, question, more than welcome to hear that. But I'm encouraging everyone, please, to go through this document, take a look. If there is anything that is needed, especially since RFC 9543, now it's published, we have a good opportunity to go revisit this model against that framework to see if there is anything missing before going to working group last call. We feel that we address all the issues, and thank you to Bo and Drew that did lots of back-end job for closing all those, but we feel that we are ready for that. With that one, I can conclude that. Thank you. Any question, comments? One thing that I want to just add to the previous discussion about the pluggables, whatever Oscar discussed, we have a session on CCAM on Friday morning. If you are still here, more than welcome to attend that to see the completeness, because you asked some question, Kriti, about that. You will see some of the background why we did the way that Oscar mentioned. But if you're interested, please attend that one as well. Okay, thank you very much.
Thanks, Raza, for the plug. No pun intended.
Hello, I'm Italo Busi. I'm presenting this draft on behalf of co-authors and contributors. Next slide. Okay, what we did on this draft, we did some changes since the last IETF meeting. We tried to clarify in the text that what is this model doing is basically providing a way for the customer to request, to express the intent to have a topology. And we think it's better to express what we are actually doing. We are representing what the customer wants as a topology rather than what is the topology that of the network exposed by the controller. We try to clarify the relationship between this model and the T-based topology, and the fact that this model does not preclude using also T-based T-topology. In addition to this one, you can do with the multi-inheritance, and you can also use this in conjunction with technology-specific augmentation from T-topology if you want to have additional technology-specific attributes when you express your intent of the topology. We clarified the relationship with the SAP topology. We was a comment from Med on the list. The SAP is exposing what the network is providing as access points to create connectivity services, while this model is again exposing the intent from the customer to have a topology. So it's not what you have in the network, but what the customer wants to get. Next slide. We also described the relationship between this draft and the ACTM VN. When we have to take into account that VN as different type 1 is providing connectivity intent, is a way to express the intent from the customer to have a connectivity service, which is more or less the same that can be done with the network slice YAM model presented by Reza, but in the end we have also the VN type Q, where in addition to I want the connectivity, I want to be able to provide the constraints on which path that connectivity needs to have. And also I may want to use the VN to provide an intent for a T topology. So this model is basically going to complement the solution in the network slicing YAM model to fulfill all the requirements that we have in VN. Next slide. Okay, actually this is not the latest version, but okay. So this is showing, for example, the fact that if you look at the overall picture, we have already two approaches to address similar problem statements. One is the VN, which is a solution set which is self-consistent with each other, and is based on T matrix and objective functions to express the connectivity intent, which is the VN type 1, to express the connectivity constraints, which is a VN type 2, which is actually an augmentation of VN type 1, and to express the topology intent, which is a topology model, which can be created as an underlay for the VN type 2. If you look at the second solution set, we have, which is driven on specify the intent through SLO, SLE attributes. We have the network service model, which can be used to create the connectivity, to express the connectivity intent, but we have a gaps today on how we can provide connectivity constraints for this intent, and as well as how to provide, in terms of SLO, SLE, a topology intent. And the idea of this draft is to complement the solution already existing in the network service model with additional YAM models that fills into the gaps. The idea is basically, if you need only connectivity, if in use cases where you have only connectivity intent requirements, you can implement only the draft, the network slicing service model that was presented by Reza. If you have more requirements, like connectivity constraints or topology intent, you can implement the other draft together with this draft. So it's intended to provide additional optional features that are to be used when they are needed. Next slide. Oh, okay, maybe you can go to slide number 12, because there was an yeah, this one. Yeah, thank you. This okay. We discussed this morning with Matt, who made a comment on the list about why not using VN type 2, and the issue is that the VN type 2 is consistently defined to be used together with VN type 1. Is VN type 1, VN type 2, and T topology are a consistent solution set. The network slicing is another solution set, which is different terminology. So if you go and try to use VN type 2 with network slicing, you can do that, but you have some drawbacks. For example, we can define the connectivity intent using network slice solution, network model, and we specify the SLO, SLE for the connectivity intent. Then we have a topology reference from the network slice to a single node topology, which is a VN type 1, where we specify again the connectivity intent. So we have a duplicated information about what is my connectivity intent, and then we have to manage what happens if there is inconsistency between these two expressions of the same intent. And then for every connectivity element or connectivity matrix entry, we can specify an underlay path, and we can over a T topology. So here we have a duplicated information between the connectivity intent in the network slicing and the DVN YAM model, plus the fact that you are using two different languages. On one side, you are specifying SLO, SLE, on the other side, you are specifying T matrix. And you have the translation, which is up to the implementation, and it's very hard to make it sure. We are basically mixing apples with oranges. So the relationship and the association is duplicated and inconsistency in the language. So having a solution that is better suited to complement the network slicing looks much easier for the implementation and also from the usability. And Matt is satisfied and would like just us to add more text in the draft to describe this issue. So you can go to the other slide. Which one? Back to where we were at the beginning. Yeah, this one. Okay. So we had also some comments about the fact that in this draft we are mixing some augmentation to the connectivity to the network slicing YAM model to provide connectivity constraints, plus a new topology type for providing connectivity intent. So as we said, we have the connectivity constraints and the topology intent. They are currently supported in the same YAM model in our draft. So what we have, if I look at the overall picture, we have 2 drafts and 2 models. And there was some request that maybe we can clean up by splitting. And okay, we discussed the different options. One option was to move the connectivity constraints into the service model, and this is another 2 drafts, 2 models. Or we can split the solution into three models, and then put 2 models in one draft and 1 model in another draft, or even splitting the solution into 3 drafts into 3 models. So we would like to get feedbacks about what is the preference from the working group. Do you want 2 models, 3 drafts? So,
Which of these options does not involve any changes to the service model?
sorry?
Which of these options does not involve any changes to the service model?
The 1, the 4, and the 5. The 1, 4, and 5 are not impacting the current network slicing service model draft. I see.
Yeah, thanks, Italo. So given the status of the network slice MBI approaching the conclusion, my preference is to have the two definitions, like connectivity constraints and topology intent, defined in the same draft, but in different modules.
So option 4.
It's option 4. Yeah.
Okay.
Okay. Anybody has any feedback?
Okay. Daniele raising his hand. He's okay with option 4. Okay. We can update the draft according to option 4 then. Okay.
Do you have any further slides?
Yes, it's about next steps, I think.
We wanted to do a poll at the end. I think
Okay.
you're running out of time, so if you could speed up.
Yep. I think it's all. Yeah, well, the next step is basically we want to address any comments and questions. So the next update, we plan to add some text to better clarify the fact that this draft is complementary with the other draft. As Medri is requesting, to have more text about what is the issue with VN type Q, and maybe we will update according to option 4.
Okay.
Okay. You can add a +1 for me. On the yes.
Okay. We have about the second poll that's up.
So I'd characterize that first poll as reasonable interest, but not overwhelming. And looking at this poll, it looks like, I don't remember the number, but I think we have more people here than the last one, which is always interesting when that happens. But overwhelmingly positive, which is great. So we'll discuss among the chairs and expect to see a poll on the list. Thank you.
Thanks.
Okay, thank you.
Okay, good afternoon, everyone. This is Jae-dong from Huawei. I'm going to give an update about the draft on the realization of a composite network slices. Okay, next slide. Here are some recap of the background. We know that the just published the RFC 9543 describes the concept of general framework for requesting and operating network slice using the IETF technologies. And network slice services can be realized by mapping one or group of network slice connectivity constructs to a network resource partition, or call it NRP. And actually, in some network scenarios, the network slices and NRPs may span multiple network domains, or it may be further sliced to provide connectivity and fine granular resources in a hierarchical manner. So this kind of scenarios, like the multi-domain or the hierarchical network slices, are considered as composite network slices. So this document describes the possible use cases for the composite network slices, and it also provides some considerations about the realization of composite network slices in the data plane, the control plane, and the management plane. It should be noted that the protocol extensions are out of the scope in this document. We just provide some considerations about the technology designs. Okay, next slide. Here we just briefly introduce the composite network slice use cases. The first is the 5G end-to-end network slice. We know that 5G end-to-end slice consists of 3 different parts, like the slice subnets is the term used in the 3GPP, the slice subnets in the RAN, in the mobile core, and the transport networks. And further in the transport network itself, the 5G end-to-end slice may be supported by a multi-domain network slice using IETF technology. And a multi-domain network IETF network slice can be mapped to a multi-domain NRP as underlaid network construct. This can be similar to the inter-domain VPN services, just it would require additional resource performance commitments. And as for the hierarchical network slice use case, I think there are multiple scenarios, including in the industry network slice, maybe you need to provide additional per customer slices. And the second is for a customer network slice, additional per application network slices are needed. The third case is in the wholesale network slice case, the customer itself may further provide network slice services to his customer. So these are the considered typical use cases for the composite slicing. Next slide, please. Here are the composite slice realization considerations covered in the current document, including the resource partitioning, the slice-related identifiers, and the data plane encapsulations, control plane, and management plane. In terms of the resource partitioning, we think that for the composite slice, it should be known that the resource need to be partitioned in each domain or in each hierarchy. But the technology used for the resource partitioning could be different in different domains or hierarchies. And the second point is the slice-related identifier. In addition to the NRP ID or slice ID for the intra-domain network slicing, for the inter-domain case, we may need to consider to add an inter-domain NRP ID when the assignment of the NRP ID in different domains cannot be coordinated. This ID may be used in control plane, the management plane, or the data plane. And for the 5G network slice case, we know that the SNSS is used as identifier of the 5G slices, but this information usually is not visible to the transport network. However, in some cases, if we want better visibility or the service monitoring or the service mapping from the 5G slices to the transport network slices, this kind of information may also need to be carried in the package sent to the transport network. And for the data plane encapsulation, according to the previous slice ID analysis, maybe we need to consider the encapsulation of the multi-domain NRP IDs and the hierarchical NRP IDs in the package. As for the control protocols, I think this document actually describes the roles of the centralized controller and also the distributed control plane. So we think they are complementary, but some of the functioning may be based on existing technologies. Well, there may be some extensions needed. As for management plane considerations, similar to the control protocols, we need some coordination among the different domains or between the different hierarchy of the network slice or NRPs. Okay, next slide. Here are the updates in the 0.2 version. Firstly, we align the description with the IETF network slice framework. And we also add a reference to the IP MPLS network slice solution draft. And in this version, we also elaborate the scenario in which the multi-domain IP-ID will be needed. We also clarify that for the hierarchical network slice scenarios, for the NRP, and may also need to be partitioned hierarchically for the resource partitioning. And this version will also elaborate the control plane of the composite network slices. Okay, next slide. We believe that the multi-domain and the hierarchical network slice considered as advanced applications of the network slice technology or framework defined in the RFC 9543. So we think this document is complementary to the base slice framework and also other documents on the network slice realization. Now the content of the document has become stable, and we would like to solicit further review, comments, and feedbacks, and also maybe we can consider working group adoption. Okay.
I saw the people on the queue.
Greg Mirsky, Ericsson, thank you for the presentation. A couple questions. So you said that a composite network slice is defined in 3GPP document?
No. We didn't say that.
Where it's defined?
I think this term was mentioned in RFC 9543. There's some example or scenarios about the composite network slice. But we further elaborate in this document.
Yeah, I think I found it's really difficult to understand what it is without strict definition. I think that it will be helpful to provide the definition of what composite slice is, especially in regard to the work of 3GPP, because it's not clear whether what's the scope of it. Does that include the work of 3GPP, or it's only related to the transport slice as defined by IETF?
Yeah, I think the scope is within the IETF.
No, again, let's not try to do it now.
That.
Yeah, but something in the future. And also, so you mentioned that their network slice identifier that is used by 3GPP might be necessary to be analyzed by transport slice. So I just wonder, is it the same as network resource partition selector?
No,
but how are they related? Are we duplicating something for the transport network while have no mapping, no relationship to the identifier used by 3GPP? So why would we need two of them for the transport network? I think that needs to be explained and clarified, because otherwise there seems to be unnecessary redundancy in information. So having defined for transport network as a network resource partition selector, and then at the same time looking over into their identifier used by RAN slice.
Yeah, actually.
So I would expect that it can be much simpler by just mapping two of them at their edge, and then using only one throughout the network. So thus eliminating this need of optionally using into their S and whatever it is.
Yeah.
It's hard to pronounce all.
Yeah, actually, I think, one use is to use it as ad for the service mapping.
I think it's something for discussion on the mailing list. Thank you.
Yeah, thank you.
Daniel?
Tara.
Yeah,
Eric?
hi. Is it me next?
Yeah, go ahead, Tarek.
Okay, this is Tarek Saad with Cisco. Thanks, Jimmy, for the presentation. Based on what you've described about this draft, you're introducing this composite network slice. I'm a little bit confused about the added value of defining this acronym. We know the NRP can span multiple domains. We already know that. We know that it needs to be provisioned across multiple domains, and the NRP selector that Greg started to talk about, we have to be aware about the selector when it's crossing multiple domains. So why are we introducing, why if there is any gap with NRP, then why don't we solve or fix the NRP across multiple domains rather than introducing a new concept and call it, this concept you're coming up with? Thank you.
Yeah, actually, the concept of composite slice is not a conflict with the term NRP. You can see it's like network slice, the relationship between the network slice and the NRPs, at different layers or levels. And if you remember, previously we have two documents. One is on the multi-domain network slice scenario, and one is on the hierarchical network slice. And the working group's suggestion was to merge these two documents into one to maybe reduce the overhead in the working group. But still, I think it's kind of a agreement that this kind of scenarios was not fully covered in the existing IETF network slice framework, and the implication on the realization need to be analyzed, and so that we can have better solutions cover these kind of scenarios. Yeah, but I think we need to clarify the composite slice terminology in the draft. That is what we need to do next.
Daniel?
My comment was covered both by Greg and Tarek. If you want one more, if you wanted to reopen the queue for one more question, mine is already covered.
Okay, don't see anybody else. Thanks, Jay.
Okay, thank you.
Thank you, Rohan. Hello, everyone. This is Luis Contreras from Telefónica. I will present this draft, which is about 5QI to DSCP mapping. We are providing here an example. The idea is to use, to follow these kind of examples for ensuring the enforcement of 5G end-to-end QoS. Next, I will present on behalf of my co-authors, Ivan Bikov and Krzysztof Szarkowicz. So the motivation of this, basically, the QoS in the slices is an essential aspect. So, and this is reflected in the fact that in 3GPP there is this definition of the information object classes regarding the QoS profile, and as well in the MBI Jam model we have the SLO, SLA template in order to reflect the importance of ensuring the quality. So the primary goal of the QoS in network slicing is to ensure the behavior that is expected by the customers requesting the slice. So at the end of the slice is an attempt of having a kind of tailored network for a particular service. So this document, with this document, we try to provide an example of potential mappings with some ideas of grouping the 5QIs or QCIs, depending on the technology that we use. And this is provided only for illustration purposes. So we don't intend to have to standardize any kind of deployment guidance. It's just to exercise what could be, let's say, a potential methodology to follow in order to having this mapping from 5QIs to the SCP. Next, please. So the 5QI or the QCIs, essentially 5QIs were defined in 5G, QCIs were defined for the previous mobile generations. So these are scalar values that are used to differentiate the QoS to be applied to different flows, to different services. So somehow it's a way of expressing an intent of the expected quality of service for a given flow.
So the FIQIs are defined in a way that they include a number of parameters, like could be the packet delay budget, the packet error rate, traffic characteristics, and some others, priorities, and so on and so forth. So because this is stated in the 3GPP level, once we intend to carry the traffic in the transport network, we need to somehow map those values or try to do some mapping of those values into the SCP values in such a way that we can ensure that the expected quality of service as expressed with the 5QIs are somehow realized in the network. Next, please. So the scope of the contribution is essentially working on this idea of the 5QIs. There was an initial attempt for doing a mapping of the QCIs to DSCP in the draft that you can see there, draft LE, TSBWG, deep cert to QCI draft. I will comment a little bit more on this later on. And what we are focusing is departing from the idea of trying to ensure the quality of service expected in the radio access network. So consider the traffic in that area. That could be front-haul traffic, mid-haul traffic, the traffic of the management system, and so on and so forth. And as said, to concentrate on the 5QIs, basically, could be a kind of incremental regarding the other effort. Next, please. So the draft entry, what intended to do, the approach of in this case was the associating or creating a kind of individual association between the 5QIs or QCIs at that point in time and the SCP values, essentially taking as the hook, let's say, for that mapping, the type of service. In the specs from 3GPP, there is this definition of the QCIs or 5QIs and a kind of service example. So that was the key somehow for trying to do the association. That association is not always straightforward and somehow can be subjective. I mean, not objective at all. But well, this was the methodology followed in that case. There is a different approach that is the one that I will explain later on, which and the one that we exercise in the draft, which is essentially to group the 5QIs according to the characteristics of the 5QIs. So somehow trying to do an objective mapping to the DSCP in terms of the expected characteristics of the flows. And we will see in the next slides. Next, please. So this is an example of a grouping. So you can see on the frame in the more or less on your right, there is a kind of legend on how the 5QIs are expressed. So these 5QIs are expressed in terms of delay and packet loss. And what we did was to take the specifications from 3GPP and trying to map this in two axes. One axis for the packet error and one other axis for the packet delay. The 5QIs are expressed in terms of or kind of 5QIs in terms of guaranteed bit rate, that would be the GBR, non-guaranteed bit rate, non-GBR, and the delay critical GBR, guaranteed bit rate. So all of them has this kind of properties, so the delay and the packet loss, and we essentially put in the map. In this particular example, what we did were to define 4 groupings. One grouping that would be the one that you can see on the left, on the most on the left, that essentially groups the 5QIs in terms of the expected delay, so very, very minimal delay, which is more or less coincident with the delay critical GBR. Then a second grouping that somehow takes the values that are around mid delay, let's say, so always below 100 milliseconds, and with different properties in terms of packet loss. And then the remaining groupings were essentially the white ones, that would be the GBR ones, as exemplary grouping 3, and the non-GBR for the rest of the categories. As said, this is just an example, just for illustration purposes. Next, please. So with that grouping, then there will be the possibility to start mapping to the different queues. Again, this is just a kind of an example. And you can see that, for instance, the group 1, that was the critical in terms of delay, can be assigned to the second less prioritized queue in this case, and so on and so forth. For grouping 2, grouping 3, and grouping 4, being grouping 4, the one more, let's say, close to best effort and being allocated to the last queue in this case. Next, please. So the next steps, apart from of collecting feedback from the working group, our idea would be to assess the convenience of this approach to get feedback for this. Also to work on providing informational examples. There are 2 examples in the draft, so probably, I mean, this is somehow open to working all of other different examples of mapping and categorizing, grouping, and then mapping to the queues. And also based on this methodology to consider implications that could happen if we follow this way in the realization models of slicing, and also to better understand some aspects that we work in this other draft, the TEAS, 5G, NSIP, and PLS, which is the mapping to 5G, 5QI aware and 5QI unaware connectivity models. So somehow we are considering this as a way of understanding further implications on the concepts that we are handling in this other draft. And I think that that's all from my side.
Okay, great. Greg?
Greg Mirsky Erickson. Yes, thank you for this presentation. May I ask you, so what's the rationale for separating OEM on arbitrary parameter, and what you see as aggressive timers and relaxed timers? Where is there objective criteria for separating this?
You mean the 5QIs, the different groupings?
Yeah, because what I noticed in your slide, I think it's a previous slide, or might be.
Yeah, to the graph.
Yeah, here. So you have OEM with aggressive timers and OEM with relaxed timers.
Well, the origin of this figure is coming from a similar exercise that we did in ORAN, in the ORAN Alliance. So that there could be different levels of OEM.
I wonder, so who says they're right?
Well, there was, I mean, if you go to the front hall schemas and so there are.
But what is aggressive timer versus relaxed timer? I really, so if we are measuring performance or we are monitoring continuity, what's the difference? What's the rate of these packets or how we're doing it? It's equally important. So why somebody says that, what's a relaxed timer? What's the value it is? Again, I'm not questioning, I'm questioning. So if you are supporting their rationale, so can you explain why there are 2 groups, two classes of OEM?
It was basically because of the nature of the service that was being managed, the front hall and so on. But I would say that I understand your point, but probably is not the key point of the draft, because this is particular to one case and for sure can be done in any other way. So we are not stating that this should be any kind of way. I said this is a kind of example. But the particular reason for that was essentially the nature of the service that was there.
But I understand that that's something that authors of this work are proposing. So they have to have some reason to do this way, to propose this as one of possible solutions.
Yeah, I think the question is noted, right? So do you want to respond on the list? I think
Okay.
you're making a valid point here.
But here the emphasis was on the bold part, not on the other part. The other part, in fact, this is not in the draft. I mean, in the draft there is the structure of the queues, but not the assignment of traffics. This is just an example. So I mean, it could be any other thing.
That's an example that is supported by a proposed model. And then the question is for the model, why the model considers that there are more than one class of OEM traffic.
But again, this is not supported by the model. But what is supported by the model is the grouping of the 5QIs. The other is somehow complementary information that could be misleading for sure. I mean, I'm not questioning that this is correct, but this is not the point of the draft. The point of the draft is the grouping of the QIs and later on the assignment to the queues. So as I said, this was a kind of particular thing for the ORAN case that could not apply or could be even wrong, but this is not the emphasis of the draft. So the emphasis of the draft is the groupings and trying to do the allocation to the different queues of those groups. Yes.
Okay,
And the
then,
impact on slicing.
okay, then in that case,
I would say let's take it to the list.
yeah, I think that the model has to be more deterministic in directing what can go there.
Okay.
Okay, less options sometimes simplifies the solution. Thank you.
Thank you.
Lou?
Just briefly, I'd like to understand the separation of this draft from the TSV WG draft, and whether and why this draft belongs here, and why you're not doing it in TSV WG. That said, please take the answer to the list because I know we're tight on time.
Okay.
Thank you.
Okay.
We have one more question.
Very general question about the objective you are draft here. I think TNG China Mobile here. I think if this one got adopted, but this one has to be done in 3GPP in order to standardize the mapping from the 5QI, QoS flow ID 5QI to your DSCP. But the thing is, 3GPP is not going to standardize this mapping.
I think this is this should not be a matter of 3GPP, I guess.
Right.
3GPP is working with 5QIs. This is how we map the 5QIs to the transport network. So I think it's somehow.
Yeah, we can talk
Yeah, sure.
offline because
For sure.
this is regarding some.
Thank you.
Participant. This is an update on the data model draft that discusses topology filters and topology filter sets. No, Oscar is taking care. Thanks. So we did present this draft in IETF 112 and also in IETF 115. We have addressed all the questions and comments that were received during those meetings. And the recently adopted NRP Young model document uses this, augments imports the topology filter module that's proposed in this document, and it uses it for the specification of the topology associated with network resource partition. So the motivation behind presenting this today is to give a very quick recap of what this document proposes and ask for working group adoption. The filter construct was originally part of the NRP model, but we decided it was generic enough to be treated in a separate standalone module. It's as the name suggests, it's used for filtering network topologies. It's the filter entry specifies a set of include all, and exclude filtering rules that can be applied to, say, your native T away topology or a customized predefined T topology as defined in RFC 8715. And application of these filters would provide a filtered set of topological elements. The topology filter set is quite simply a union of multiple topology filters. It comes into play when you are trying to apply these filters as a collective on the topology. And the model, the way it's defined, it can be used both on the network element and also on a network controller. Next slide. There are a couple of use cases that are discussed in the document. The specification of the topology associated with NRP is something that I mentioned. It's already part of the NRP Young module. Some of the examples of the specification are listed here. Another use case rather that we specify in the document is the specification of topology related constraints for T path computation. We do acknowledge that we do have a way to provide a topology related constraints as part of other modeling efforts in the working group, but we are looking at this as a tool that can be used for more advanced and complex filtering requirements. The rest of the slides go through the model structure. Nothing has changed since the last time, so I wouldn't be repeating all of that. You can go through them in leisure and reach out to the authors if you have any questions. So let's jump to slide 9. We believe that the document is sufficiently big for it to be considered for adoption, especially since it's already being used in the NRP Young document. At this point, we would like to seek inputs on what else can be added. But yeah, we would really like to see this get adopted. questions?
So we would like to poll this. So same questions. First one. So this looks pretty similar to the last one, not overwhelming participation, but those who are participating are interested in the topic. Same question 2. Is this a good starting point? Again, this is adoption. And interestingly enough, the same type of results. We have more people participating in think it's a good starting point than we're interested in the topic. So that's pretty entertaining. We did get a couple of no's on this one as well as the previous one. For those who are saying no, we'd like to hear your opinions during the adoption poll that will take place on the working group list. Okay, thank you. And moving to the next presentation.
We are down to the last presentation. This typically any RFC 4090 based documents, we progress them in the MPLS working group and have TEAS informed of it. But the focus of this draft seems to be primarily on bandwidth protection and reservation. So it seems appropriate to be discussed here, but nevertheless, the TEAS chairs will have a conversation with the MPLS chairs and figure out what's appropriate. Rafal, go ahead.
Good morning. So we come up with this draft to address particular challenge. Can we move to the next slide? So first of all, disclaimer, I'm speaking for myself, not for my employer. Please move to the next one. What we see as a typical implementation of the bypass protection is that we do not reserve the bandwidth for or even try to think about the bandwidth when we signal the bypass LSP. Therefore, it goes through the shortest path between PLR and MP, which is of course not sharing the fate with the protected resource. However, that means that the bypass could be routed through the totally utilized resource like link, or even a link which has not sufficient capacity. Therefore, when the bypass is activated, we could observe losses, congestion losses along the path taken by bypass. So that's one. And that's what typically is happening. Could we move to the next one? Of course, we could potentially reserve bandwidth and signal the bandwidth for bypass, but then we reserve capacity which will be barely used and used for a very short period of time. And even more, we will reserve more capacity for bypasses than for actual traffic, because typically on the single resource, we may have multiple bypasses protecting unrelated and unrelated resources, right? So which doesn't fail at the same time, but we reserve bandwidth as aggregation. Okay, so next slide, please. So here is our draft, mine and John, like a proposal, which basically says, let's run the CSPF for the bypass with some bandwidth which represents protected volume of traffic. However, find the ERO. However, do not use these bandwidth number as for reservation in the RSVP signaling. There we can use something significantly less or even zero. So no reservation, but the path is computed along the path where available bandwidth is sufficient to handle the protected volume, protected bandwidth. And of course, this bypass needs to be optimized and recalculated on the events, but not too frequently to not overload the network. Could you move to the next slide? Of course, the first step is we need to understand how much we are protecting, how much volume the bypass is protecting. And this could be done locally on the PLR by just looking on the LSPs which are protected and what is their bandwidth reservation. How to do that? The proposal here is just do this periodically, store it, similar to what the auto bandwidth is doing for regular LSPs. Plus some minimum bandwidth, which will be good for bootstrap bypass when it's first time signaled, or as a fallback when the CSPF cannot find the path for the derived protected bandwidth. And of course, other procedures are possible, but that's part of the draft. Could you move to the next one? I wouldn't spend too much time on this one. It's more for the documents. The main point is that because there is no the bypass capacity is not reserved, so it's not visible in the traffic engineering database. So we are not overbooking, or we are not booking the bandwidth for the bypasses which are for unrelated failures or just use it by minutes. So could we move to the next one? The last part was optimize bandwidth infrequently. Of course, we have to calculate ERO for bypass and signal the bypass when some event happens, right? Like a periodic optimization, that's one. When we have the bypass tunnel failure, signaled by path error, path tear, whatever happens along the bypass path. When the bypass is initialized first time, first LSP comes and needs protection. And of course, in theory, it's possible that, well, it would be nice to optimize the bypass every time the protected LSP bandwidth reservation changes, but that could lead to just too much churn. So the proposal is to explicitly to not do that in order to conserve the compute resources on the network and reduce the churn associated with the bypasses. Could we move to the next slide? So yes, we admit this is not a perfect solution, right? Because we are not because there is a inherited risk of two bypasses of related resources, like belonging to the same SRLG, will be routed across the same bypass path together. And because we from distinct PLRs, therefore, and because we are not reserving and we are not modifying the traffic engineering database, therefore it could lead to the situation where we create like dual booking or overbooking of this available capacity. However, a random fill algorithm should help with that. The other thing is that, yes, this is a local behavior of PLR, so there is no change in protocol that allows for gradual deployment, take the benefits out of the first devices with network which supports that. No really interoperability challenges are posed by this proposal. Um, okay, and I think we can move to the last slide, because the draft is have been published a few weeks ago, or month maybe. And we are already get some feedback from the industry, from vendors specifically. We are looking to update the draft to version 01, which will provide the alternative approach, which is contributed by Juniper engineer, mostly focused on the available bandwidth, and therefore do not require computation of the protected bandwidth. The essence is that the bypass will be routed along the path which provides the max available bandwidth and could be bounded by hops and other attributes. But the optimization point in this additional or alternative approach is available path bandwidth, not the TE metric. And that's a preview. That's about this draft. We are not seeking to standardize it. It will be rather follow the information path. But we are seeking the more industry, like a contribution feedback, to make this more solid. That's all from me. I'm open to question.
You have one person in the queue, Greg.
Yes. Thank you, Greg Mirsky, Ericsson. So it seems that what you're defining, your new terminology, is analogous to committed information rate, access information rate, or is it just my impression?
I think it's your impression. The protected bandwidth, which is the available bandwidth, is already defined, right? This is what we have in the traffic engineering database for the RSVP traffic engineering. The protected bandwidth is the only thing which is really defined here new, and it's just how much of what is the volume protected by bypass. Is it committed information rate? We are not doing any admission control here. We are not rate limiting or dropping anything. We just say, well, we could periodically check how much bandwidth is carried by the protected LSP, and not by measuring the volume, but by us doing the math, adding the reservations of these protected LSPs, right, from the soft states. So we know how much we protect, and then find the path which has enough available capacity to handle that. So I don't any.
But actually, if you are signaling reservation lower than what's in protected LSP, then you are reducing the CIR.
Could you repeat the question?
So by signaling lower bandwidth on your protection, then you are reducing your committed information rate. So basically, you are allowing more traffic more of your protected traffic to be squeezed out and dropped.
Yeah, that's true. I think all that they're saying is today, most of the networks run with zero bandwidth bypass LSPs, and they rely on global repair to take care. The issue that they're trying to solve is the traffic tends to stay on the bypass LSPs for far too long, and all that they're trying to do is figure out ways to reduce the amount of congestion that can happen.
Yeah, but infinite number of ways to do that. So are we going to document each and every way of documenting how this protection bandwidth can be allocated and how that can be controlled? I just wonder.
I agree with you that there is not only one way, and the proof is that we just discussing the preview of 02, which will say, okay, there is another way of doing that. We still could. So if we do the reservation for the bypass, that's expensive. It's technically the greatest, right? We reserved capacity and we know we have a capacity, right? In case of the switch over to the bypass. However, this reserve capacity is a lost capacity, right? You cannot use it for anything else. You cannot double reserve there. So you have to pay a lot for extra capacity in your network, which will be used only for that.
Well,
try to avoid that.
Okay. Have you looked? No. Have you looked at RFC 7412? So basically, for protecting different business cases, it recommends using different cost markings so that the more critical traffic will get better treatment. So that way you can achieve better utilization of your protection path in mesh topologies. So
Okay.
again, so my question is, what would be the value of working group working on that and publishing this document if that's your goal to publish a document? Thank you.
So first comment to QoS, it's orthogonal or additive. If I wrote the 1 terabit, the bypass protecting 1 terabit over 100 gigabit network interface, it doesn't help me much, even with the QoS, depending, of course, of my QoS or class mix on the traffic. If I can find the path which is maybe not 1 terabit, which has 1 terabit available capacity, then it still could go to the QoS congestion and drops, because there could be 2 bypasses which goes that path, but it's not. But I have higher probability that these losses will be less. So that's one. And the what I think about the value of that, documenting these ways to how we can optimize the bypass path routing, I would say it's awareness. It allows implementation and easier.
Yeah.
Well, it
so
just
Rafal,
gives me additional tool. Let's say this
Rafal,
way.
I think you made your point there. I think you can try and elaborate more about that on the list. We still have a couple of people in the queue. Let's quickly take the questions. Tarek?
Hi, Rafal. This is Tarek Saad with Cisco. Thank you for the presentation. Interesting work. I think I heard you highlight the risk that if you have 2 independent PLRs, or maybe more than 2, computing a bypass, because we're not doing the reservation of protected bandwidth, they could end up all picking the same set of links. And that could translate to overloading in case of a failure, overloading that bypass path. So if you highlighted that I agree with that. Did you consider reserving the protected bandwidth in a different bandwidth pool, different from the actual reservable bandwidth that resources in your network have? Have your protected bandwidth sitting in a different bandwidth pool? That is my question.
So yeah, of course, but that would require, according to my knowledge, because this bandwidth pool cannot come out from the, if it comes from the just interface pool, bandwidth pool, then it's taken out from the interface capacity, right? So it's the same problem as reserving that from the priority free, for example, right? It's either there or not. Potentially, we may have like a virtual capacity and reserve it, but that would require, I think it will require some changes to the IGP to have this separate bandwidth. I don't know.
So yes and no. Maybe I will take it offline, but there was indeed in IETF the DS DiffServ traffic engineering with MAM model and RDM model. So
That
some
would not help because
Tarek,
if
yeah.
I will take it offline.
Can you take it to the list? Yeah, thank you. It's a valid point. Let's go to the last question. Gyan?
Yes. Can you hear me?
Yeah, go ahead.
Yeah. So I was actually, so in the draft, or I think in the slides, it didn't mention whether this was related to RSVP-TE, and I guess somebody mentioned like the MAM allocation model, like the DiffServ TE, or is this a new constraint possibly for SR policy, and maybe possibly applying the similar types of constraints that are used with RSVP-TE, but applying that same concept to a for path protection with SR policy. Thank you.
Okay, this is in the context of RSVP signaling and.
Okay, so just RSVP. I see. Okay, all right. Thanks.
Yeah.
Okay. Thanks, Rafal. I think we are 1 minute over. Thanks everyone for a very productive session. See you all in Vancouver. Hopefully everybody who's online can also show up in Vancouver. Thanks.